about Newton. He did a degree in Cambridge and completed that degree in 1665 when he was 23. But k is just the distance between f of x plus h and f of x. As you can see from the diagram, that is the same distance as that. So I can replace k with f of x plus h minus f of x, the distance between these two values. So I'll do that. And what I have here is an expression for the gradient of a straight line. So remember, the gradient of a straight line we'll be talking about as f of x plus h minus f of x divided by h. The change in y over the corresponding change in x. So if I draw a straight line that just touches the curve and then continues on, we have what is known as a tangent. And the gradient of this straight line, we've talked about what the gradient of a straight line is, will be, by definition, the gradient of the curve at the point P. So we now need to somehow try and find an expression to represent the gradient of this tangent. In this case, the equation will be y, or f of x, is equal to x squared plus 3x plus 2. We always write down the same formula, dy dx equals the limit as h goes to naught, f of x plus h minus f of x over h. And we just substitute into this formula our f of x plus h and our f of x. So doing that, f of x plus h here is replaced with all of this. Minus f of x. F of x was this. So writing down what we do have left, we have those three terms on h. And again, notice all the terms have a factor in h in them, and I can divide through by h and get rid of that factor and hence rid of the bottom line. So 2xh will just be 2x, h squared divided by h is h, 3h divided by h is 3. So I get 2x plus h plus 3, and I can now take the limit. In other words, replace h with naught in the expression. So it's 2x plus 0 plus 3, which is 2x plus 3.